So welcome everyone. My name is Zibi Braniecki. I am a vice chair of Unicode ICU4X technical committee. And this is Shane Carr, who I am usually assisting. He is the chair of the ICU4X technical committee. The two of us are also founders of the project ICU4X. And on daily basis, Shane leads the engineering, architecture, planning, and design. And tomorrow he's going to be talking more about the big deployments and advancements in the project. And today I have an honor to introduce you to what ICU4X is, why it exists, and how it may help you in your developer journey. And let's see how it goes. It's a first time we're presenting this in a couple of years, and things have changed. So there may be some quirks, but I hope that we'll go through this smoothly. My recommendation is that if you have questions, please ask them as we go. Don't leave them for the end. We have 1.5 hours, which should be more than enough to cover the topic and touch some more advanced subjects if we want to, or steer in any direction that you will find particularly interesting to you, which I hope you will find some. And also, if at any point what I'm saying makes no sense, please also stop me. It's technology and internationalization in particular has a lot of jargon and has a lot of tribal knowledge that is passed from generation to generation. And I remember being where you are and learning about the industry and the knowledge required to operate in it. And I absolutely remember people glazing through terminology that made no sense to listeners and leaving us kind of to collect the scrapes. It's also that I happen to be ESL, which English as a second language, which in internationalization usually serves me as a superpower. But when I publicly present, I sometimes think in Polish and speak in English, and that may become confusing for you listeners. So please do not hesitate to pause me, raise your hand, ask a question, and we can talk about, and I can try to explain the subject a little bit better. So we're going to talk about how the internationalization works on a technical level. The slides will be available, so you don't necessarily need to take the pictures unless you really think that it's beautiful. I'm happy to share them later. We'll talk about some challenges that we're trying to solve. Internationalization is one of the largest domains in computer science, and it requires many, many years to develop, which a little bit like law ends up meaning that fairly often we are trailing the advancements in the technological stacks. It takes us many years to build the foundation in which we can create global software. And the whole stack is fairly complex. So I would like to try to give you the outline of how it looks like. We'll talk about ICU4X, why it exists, what purpose it's trying to solve. Then we'll work on something interactive, building a first ICU4X app yourself so you can see how it feels. We're going to allow you to do this in one of the two programming languages, JavaScript or Rust. The reason why we're doing this is to show you how one of the value proposition of ICU4X is that it's a single code base that can be used in many programming languages. And then we'll talk a little bit about data pipeline, and maybe we will get to the custom data, which is the advanced topic. But this part is a little bit fuzzy. Please bear with us. I'm so sorry for this, but we've been releasing updates lately, and the tutorial part of that requires a little bit of work. So my chair is right now helping me by preparing some adjustments for your JavaScript tutorial part. And then we'll wrap up. So internationalization, assuming you're here at this conference, I will take into account the idea that you know what this is. But at least remembering my first Unicode conference, I would not say that I had a very good understanding of the difference between localization, internationalization, globalization. There were terms floated at the time, like globalization, and internationalization, the way I define it for the purposes of my project. By the way, I didn't introduce myself beyond the fact that I'm a vice chair. I built ICU4X and served in Unicode for 5 years as a representative of Mozilla, working on Firefox web browser, Gecko engine, and SpiderMonkey JavaScript engine. And then for 4 years from Amazon, working on Vega operating system and the tech stack that powers Amazon devices. So through that career, I had a chance to introduce internationalization to a lot of engineers, managers, and designers, UX people. The way I try to define it is that internationalization is the part of software that is making your software translatable or adaptable to all languages, which is different from the process of adapting it to a particular language. So if internationalization is done right, it is not impossible to scale. But then localization is the part that actually does the scaling or adaptation to each language. Internationalization is very compute and data heavy. It requires a lot of nuanced computations because over last 5,000 years, humans developed cultures and languages in a very sophisticated way that is not really encodable easily in imperative logic and requires quite a bit of data. But what it gives you in return are little building blocks that fit into the interfaces, predominantly right now graphical user interfaces, although we are increasing the scaling to voice interfaces and multi-modal interfaces and ambient computing. But all of the pieces that allow you to format a date, format a time, understand the date, understand the calendrical system that a person is using, format text, break lines, all of that is involving internationalization, and then adaptation to particular language will be the localization. So it starts generally in this industry with a project called Unicode, who is the organizer of this conference. And it's a fairly unique experience in the world of technology. If you think about other domains like security or graphics or encryption, you don't really have a single non-for-profit body that collects all the organizations that are working together on advancing that one discipline of software engineering. Generally, every company does it on their own, or there are collections of companies or open source projects. But with internationalization, we were very successful and lucky that great minds that were here 20 years ago or 25 years ago understood that it's such a complex problem that it's good for all companies to work together. So Unicode has representatives in all major software vendors in the world who work together to make all of our software adaptable to all languages as a shared good. And when Unicode is done right, you have Windows, macOS, Android, Linux, Huawei, all of the companies can use internationalization, but also individual people building their smaller projects can also use Unicode. So one of the biggest projects in Unicode, and one of the most challenging, is CLDR. You can think of it, or at least I'd like to explain it, it's like Wikipedia for internationalization data. It's a common resource, it's a database that linguists, technologists, and speakers of languages around on the planet are collecting in a single place encodable information about how this language and this culture represents and expresses different aspects of itself. That can be dates, numbers, commas, punctuation point, formatters, pluralization rules, declensions, names, eras, calendrical systems. All of that is encoded in CLDR. And CLDR is accessible on its own. You don't really need much more. It's an XML file or JSON file. You can download it from GitHub, and you can write your own logic to use it. So it's fully accessible without any further processing. But of course, we do provide a lot of computational libraries that are operating on this CLDR. Then this ICU, which is the project that contains code that operates on CLDR and information from your code or from users or together to present the internationalized UI to the user. And then there are platform APIs that make things simpler. For example, if you write in JavaScript, you have access to JavaScript internationalization API, ECMA 402. And that gives you all the building blocks that are powered by ICU and CLDR, governed by Unicode. And then you write your application on top of that. So what are the challenges? That pyramid that I described to you was created long time ago, before my time, before Shane's time. And the technology that we've been building on at the time was very different. Majority of computers were large mainframes in IBM data centers. And the number of languages that were reasonably accessible on the internet was much smaller. Majority of the world was not connected online. It was predominantly 5, 6 rich countries in Europe, North America. And as we started fulfilling our mission as Unicode and adding more languages, the amount of data started growing quadratically. And that represents a challenge when you try to move from massive data centers to your smartwatch. And you try to present a date for all users on the date. It's also business, from the business perspective, there are costs of increasing number of languages. We know that for clients of software, we see a drop in number of successful downloads. The download funnels are getting hit when you increase the size by 100 kilobytes. So a lot of organizations, for example, when I was working on Firefox, one of the biggest challenges we were facing is what languages to support. And it's a very challenging moral question at some point, because you're standing in front of the project manager who is saying, well, we don't want to make Firefox 1 megabyte bigger to support native tribal Amazonian language. We don't have a revenue out of that. So it becomes a challenging question between the discipline of internationalization, whose goal is to make software accessible to everyone on the planet, versus which customers on the planet are valuable enough to justify translating things for them. And then you have slices of number of languages, but also what kind of data you have per language. And as I started mentioning, the landscape of devices started changing tremendously. Smartphones, wearables, smart glasses, pins, all of that technology starts having user interfaces that should be accessible globally, but represent exactly what I described to the extreme. So there are people in multiple companies trying to decide how many languages a watch should support. And the larger the data, the more costly the trade-off. And the failure of internationalization industry would be if the conclusion was that a website on a big server can support 200 languages, but a smartwatch can only support 4. Or some massive computer can support a lot of languages, but your voice assistant can only speak 10 because it's too costly to scale it to more people. And that we know there are going to be talks tomorrow and the day after about the impact on language survival of technological adoption of languages. We know from experience that young people learn languages that are accessible on their devices. So if WhatsApp or Facebook are not accessible in some language, it actually affects the culture, the survival of a culture. Finally, the challenge that we've been facing in internationalization is that if it's complex and it's large and it takes many years, the worst thing that can happen for us is that you guys are starting to change languages that you work with. 20 years ago, everyone was writing C and Java. Could you please stay and use only those languages, because then we have the solution for you. But if you want to use PHP or Dart or Python 3 or Swift is becoming popular, that represents a massive challenge. Because now, from the business perspective, another question pops up. How much investment it's worth to put into, what is the language that is growing right now? Objective-C internationalization, and how many years it's going to be popular for? How long are you promising to use it? Because if you're going to try to switch to another language, we will have to bring the whole code base into another language. And as I said, internationalization as a service has been tried, and it doesn't really scale well. Users are not comfortable waiting for translated strings to show up at the latency of network connections. Rich user experiences require instant feedback because you're toggling buttons and it should adapt to the plural form and show you the right date, and trying to send it to the server to say, hey, translate this date for me or make this sentence sound right. It just doesn't work. And we also are increasingly bringing computation and user interfaces to areas where network quality is degraded. People are using technology in scenarios where they are not continuously connected to high Wi-Fi. Yeah, so we knew that we have a wish list for a scalable internationalization library. We only want to pay for what we use. We want to scale number of locales per demand because different businesses have different needs, and adding a language should be easy. We would like it to run on all kinds of devices, from large to small, scale to larger number of programming languages that people will be using tomorrow, and yeah, run everything offline. So here comes ICU4X. It's a portable by design internationalization library. It's lightweight, and it's written in a programming language that minimizes the risk of one more vector of attack on software, which is that internationalization historically has been one of the ways to crash software. We are Unicode. We are under Unicode. There are 3 main companies right now contributing to ICU4X: Mozilla, Google, and Amazon. It's open source. We have a large number of contributors. Shane is going to be talking about this tomorrow. And if you have an interest in contributing, it should be fairly easy. You just come to our GitHub, look at the contribution guideline, and pick something easy to start with, and we're going to help you. The journey was fairly long. As I said, one of the challenges is that we will always be trailing. 3 years from now, you're going to be using the next programming language connected to LLM in your vibe-coded editor, and we are going to be still building for multimodal user interfaces that exist today. We would like to be able to scale to the needs of environments and user interfaces of tomorrow, but it's not going to be a 3-month vibe-coded project. Like, that's the timeline that I would claim is fairly fast. We identified the problem in 2019. We started in 2020. 2 years later, we had the first version of ICU4X. A year later, we were able to put it in first large products. And this year, we released a second major version, and it got included in the larger operating system in the world, Android, and the most popular web browser in the world, Chrome. Yeah, so things that, places where you can find ICU4X. My smartwatch is using ICU4X to show you date and time. Many data centers, you can plug it to using Canvas Kit. It uses the WebAssembly port. If you use Firefox, you use ICU4X. If you use Chrome, you will use ICU4X starting December. Anything related to Unicode properties, and if you use Rust, their messages are internationalized using ICU4X. So as I said, one of the goals we had was to escape this patch of we invest in creating an internationalization logic in PHP, and people abandon PHP. So we moved to Python, and people abandon Python, and we moved to JavaScript, and like basically as languages progress, we get stuck, and the cost is incredible to bring the same logic to another programming language. One of the nice things about Rust is that it did provide us a really good bottom layer of fast native light software that can be exposed to many programming languages. And here's an example of a demo of ICU4X implemented in Rust running in your browser via WebAssembly. It's using a project called Diplomat that we also developed that allows you to expose your Rust code to any programming language. We have bindings to, I think, 6, 7 programming languages, and the number of programming languages is increasing as new programming languages adopt ICU4X. All they have to do is scale the tool is called Diplomat. Everything else comes for free. It's also fast and tiny. We were able to drastically reduce the code size required. There's no magic in it. In both cases, the ICU4C and ICU4X are just pure code. And it's not that Rust is somehow creating smaller code. It's just that we are designing it and developing in 2025 rather than 1998. We are able to not target or think about solution in form of what an IBM data center can support, but rather think about what a smartwatch needs. And what a smartwatch needs may only be formatting time. So instead of ICU, which is international components of Unicode, being a single intermingled network of components where time formatter uses number formatter depends on the data that also requires date formatter, that requires plural rules, that everything requires everything, and you just basically have a choice. Do you want the whole blob or you do want nothing? We were able to benefit from more modern environments to create a series of small packages that are standalone. So if you only want to format time, you're pulling an absolute minimum amount of data, both code and data payload required to format time. If you need everything, you pull everything. But majority of customers have slices of needs, and we are able to offer them, as you can see, drastically smaller code size and better performance for multiple reasons. One of them I'm going to be talking about in a moment. So we're half an hour into the talk, which is right on time. I'm very surprised. Do you have any questions about what we talked about so far? No, I explained everything perfectly. Impossible. Okay. No questions? Okay.
All right. Can you say your name and your question?
Yeah, my name is Feng Shi. I'm a med student. I'm not an engineer, so absolutely stupid on this. But could you explain a little bit more on, say, today the interface is increasingly voice-based, and how does that add complexity to your work, and how do you address it?
Aha. Wow, this is a really good question. I happened to spend 2 years working on Alexa internationalization, so thank you for the question. So what we are trying to say is that it's not, we use the term multimodal because instead of thinking of creating a separate solution to voice internationalization from graphical user interface internationalization, we want to talk about the fact that humans are multimodal. We communicate using multiple modalities, and technology should communicate with us also using multiple modalities. So I would describe it, okay, let me try. There are three major challenges. One, and this is going to be an intro for you into a history of Unicode, but when Unicode and ICU was designed, one of the early challenges, there were of course a lot of challenges. People were trying to figure out how to translate messy human cultures into computers, which is very hard. And they had to cut corners. And it's not that they were lazy or they didn't want to solve the problem, but they decided that some problems are way too complex. And if they try to solve everything, they will solve nothing, and we will have nothing to use. So one of the early decisions that they were able to escape with is that ICU and Unicode is not really designed to parse inputs. It's predominantly focused on creating outputs. So you have a computer date and you speak Mandarin, we can format your date to Chinese. You speak Japanese and you use Buddhist calendar, we can format it to Japanese. But if you try to type your date in your calendrical system, in your language, and you hope for the computer to understand it, we don't really have a good system for that. And we were able to escape it, and you haven't noticed that your phone doesn't really do this well, because no one really types dates. We created widgets, we created selectors, we created tickers, everything to kind of avoid you trying to just tell us, because we really cannot understand you well. And that, of course, does not scale to voice. Because in a voice interface, when I tell you, when do you want to go to a movie, you're going to tell me, and I have to understand you. And what you mean may understand not just on your language and an accent, which are problems that we have been solving for a long time with speech-to-text models, but we also have to, after we have this text, we have to understand what this text means. Did the 11 mean the day or a month? Are you telling us the hour in the 24-hour clock, like 9? What do you mean by 9? Which 9? All of that is culturally complicated and ambiguous. And our experience with users is that the last thing you want us to do is for your voice assistant to say, did you mean? No one wants that. We want computers to get us because humans get us. But humans have much more context. So that one of the biggest challenges when we enter the area of voice is that we can no longer escape the need to scale to inputs. The second one is that formatting to display and formatting for speech are different. Very often, the message you want to see on the screen that captures information would sound awkward spoken. And we have not really escaped that. If you start paying attention, that may be a little bit like, you know, ripping the curtains and now you see behind the theater. If you look at your phone and you try to ask it to say what it sees on the screen, it will start reading you dates, and sometimes it will say something like, today is 12/09/2025, and no human would say it like this, right? Like, it's just basically the computer trying to show you what it says. And the same goes with currencies or with like numerical calculations, saying, you know, things that your eyes glaze over when you parse, because you're really good at parsing. So when you parse and you see 1.0 star, you're okay with it. But if the computer would say that you have 1.0 stars or star, it starts sounding odd, because in different languages, fractional digits are pluralized differently, and it all becomes really messy. So what we have to start doing, and we have been in Alexa, is separating messages constructed for spoken and displayed user interfaces. So you will have the same message in two modalities, targeting two modalities, and that depending on the modality, because it's often dynamic, we are increasingly having computer systems where whether we are going to say it or display it depends where your eyes are. Are you looking at the screen? Are you looking away from the screen? Can we display it to you? Is it sufficient? It's becoming more and more important in infotainment systems in your cars, because we have to understand the context in which you're operating to understand how to give you this information. Sometimes it may be important, like warnings. So all of that has to be adapted to different modalities. Input-output modalities. The last part I would say is that that may be not specific to voice, but the branch of internationalization in voice and in graphics have been kind of developing in parallel over the last 20 years. So while Unicode and all large organizations have been collaborating on how to make your UI systems format and display internationalization properly, the academic machine translation community have been working on advancing large language models, what now we know as large language models. And the goal was to create a single large language model that will speak all languages of the planet and speak those languages and understand those languages. And we're pretty advanced there. But those two disciplines have been parallel, but completely different. One is deterministic. I can format the date for you, and I swear that this date is going to look the same way today and tomorrow. And if you show me $1 billion or $1 million in French, formatted on your computer, it's going to look the same way every time because it's using the same algorithms and the same data. Now with LLMs, inherently you will never have this certainty. Like, it's impossible by design to make sure that LLM is always going to display 25 Celsius. You can't. That's just not how LLMs work. It's not hallucination. It's not a temporary limitation. It's not going to go away in a year. It's not going to go away in 3 years. Non-deterministic system is going to remain non-deterministic. Like quantum physics and Newtonian physics, merging those two is really tricky. So a lot of work goes into the question of LLM can sound really good, and it can tell you a story or a joke. But if you ask it at which temperature water freezes, it's not about knowledge. It's that there is nothing in the system that protects it from saying 5 Celsius. Nothing. Because there's no reason for LLM computationally to not answer with another data that happens not to be correct one. It doesn't matter for LLM. The sentence sounds good. Declension is proper. Pluralization is correct. The number doesn't matter. So what we are trying to do right now, and this is one of the biggest challenges, and quite frankly, I have no privileged knowledge, but as an external observer, I think one of the reasons why companies like Apple are very cautious to introduce LLMs into the system is that getting to the point where you have this system which can build correct sentences but put the right data inside them has been prone to errors. And whether you release it to customers because they want a fun system that speaks and understands languages and are okay if it sometimes gives you the wrong data, or systems where you cannot afford a mistake, that really depends. That really determines which companies are more comfortable with releasing those kind of systems and which ones are holding on until we solve this problem, which, yeah, it's incredibly hard to solve. I hope that answers your question.
All right. Any more questions, or are we ready to go to the first tutorial?
Yeah.
The first lesson.
Let's have fun. We are going to build some ICU4X application. So it's going to be very simple. If you've worked with internationalization, there's going to be nothing surprising about this, except that I would like to emphasize that you're going to be working exclusively with ICU4X, which means that even if you work in JavaScript, you're not going to be working with what the browser provides you. You're going to be working with what ICU4X that you bundled into your application provides you. That gives you more control. For example, Right now, in the demo, it's not going to matter as much. But if a browser doesn't have a language that you need, or if the browser doesn't format something the way your UX team forces your company to format something, with a browser, you can do nothing. Well, asterisk, not nothing. You can come to Unicode and discuss how in a given language currency should be formatted or something like that. But it's not easy. It's going to take years before it's going to get solved. But you can bring your own solution, and this is what we're going to work on, and then you have full control over how it works. Historically, as I said, it was impossible because if your website was to use your own ICU, your website would have to download 40 megabytes. Right now with ICU4X, you can have your website download 80 kilobytes and do the formatting. All right, so get your laptops out. You can choose Rust or JavaScript. If you happen to speak neither of those two languages, have fun, try one of them.
Partner up. If you can partner up if you're not familiar with Rust and JavaScript.
Yes, and we will be here, both of us, and we are available to help you with any piece that you may need help with. And what we're going to do is in Rust, in order to avoid scope creeping our application too much. Here I'm doing project management. We're going to write a command line application. So it's not going to be shiny. There are not going to be many colors, but it's going to do the functional thing that an application has to do in order to display international output. In JavaScript, because it's already in your browser and it already has HTML, we're going to use the HTML forms to allow you to put input and display output. And you can use, I think like CodePad is one of them, like a live online editor. So the documentation is readily available to you. I actually want to show something separately because traditionally internationalization doesn't have a lot of that, but we actually have a website. The website has hopefully fairly readable quick start with code examples, interactive demo that I was showing you before. Please open. Okay, where you can like basically look at anything that you can do with ICU4X and play with interactively. This is ICU4X compiled to JavaScript through WebAssembly. You can look at the documentation, API documentation for Rust, C++, Dart, and TypeScript. Please open, please open. C++, Dart, JavaScript, yes. You have no idea how much it takes us to maintain those links so that they never break as we evolve the project. But you can have like here are examples, and I will recommend you that you actually open at least the ic4x.unicode.org. Look so that you have access to tutorials and API documentation. Right now, we're going to be using those two aspects of it. And I will encourage you to play with it a little bit and like try different things and different components so that you can scale out of the minimal pieces that we've been showing you. I'll give you a moment to copy and paste with your eyes and fingers. It'd be really cool if you could just like point and drag and drop onto the, we'll get there. Okay, may I move forward? 3, 2.9, 2.8.
I can also rewrite these up on the whiteboard if it helps. These links,
Maybe just like
as well as all the other links are.
Maybe just like write the basic one, the ic4x.unicode.org.
Yeah, I'll write that one because all these links you can get to from ic4x.unicode.
Yeah, so our main page like has all of those links, and you can go through like much more. A lot of that is a lot of our website. And that's another maybe novelty. And a lot of our website is actually designed for people at your point of learning about this, rather than at people who look at it every day, which a lot of internationalization happens to be very focused on advanced users. We really try to make sure that everything that you encounter is kind of like friendly for learning the basics. You can open the whole link, but like really this domain is what matters here. As long as you can type those 5, 7, 10, 15 characters, we're good. And Shane is helping us with some of it. All right. I am going to press next slide. Unless I hear verbal, explicit opposition. 3, 2, 1, go. Okay. So now is a second link that is a link to particular exercise. It has 2 documents in it. One document is for JavaScript, one is for Rust. It has only 4 steps. So for the next 20 minutes, you have plenty of time to copy that link. This is, by the way, normal X. I have no idea how this font does it. It's not a Unicode character for multiplication. This is X. I have not designed this font. Okay, so what you should see when you open it are 2 documents. One is that introduction to ICU4X in Rust. One is in JavaScript. Scroll to the document that you like. It has 4 steps. One of them I recommend, I think it does recommend using CodePen. So I'm going to open this link in a moment myself.
I can go ahead and help you with copying that link onto the whiteboard.
Yes, so for JavaScript, we recommend using CodePen or something similar, but I play with it with CodePen to validate it works. It just allows you to like paste your HTML in JavaScript, and you should see the right things at the right time. Again, we have 20 minutes for it. It should be plenty of time to just copy paste it.
Okay, I copied the link over here, so you can
Yes.
you can open the link on the screen if you want.
And this is the time where, like, if you stumble upon something, if something doesn't make sense, if something looks too red, please raise your hand. We're going to come to you and help you. That would be wonderful. Unless you want to do something else, I will not. Yeah, your time. But the goal is to show you like how you would use a component in code. Mm-hmm.
I fixed the next.
Oh, thank you. Okay, so let me. I do have an extended screen, so let me. Sorry, not sheet slides. And Unicode. And we have to open this one. And you say that it's here.
This URL, it goes to, if you click it, it goes to the file called data management.
Mm-hmm.
It should go to the file called datepickerData.md because this has the JavaScript and the Rust sections.
Okay.
And I also will get pull request inside a file from the JavaScript blob file to Zibi. So I just send it out.
Did you merge it?
I'll hit merge it.
Perfect.
This is the HTML file.
You've got your instructor and TA here to help you. Just raise your hand or look our way or look sufficiently bewildered and confused and we'll come over to help you.
maybe do that first.
I think it's
Because I think
So why don't you go back to the.
no, that's what she's trying.
Oh, okay.
Yeah, I'm not at rest yet. I'm not there yet, but I can use Flutter. So the HTML is loading properly. This is, yes, there. That's one. Yeah, RC. Great. Backlog.
Yeah, because that's. Yeah.
While you're working, I would love to take a picture of the group just for my memory. If you are not interested in being in the picture, please raise your hand and I will not take a picture.
You send it to me.
Thank you.
So what did you put?
I'm just gonna see that it was Christmas, and I don't understand. Just
Oh.
okay, so this, right, so this here, okay, basically what's happening here, so you see it loaded, right?
Oh.
So this,
Yeah.
so this is just up there, down errors. There's a label saying how, here's the and it's an English, right? And so the ID is output. And then the output, it will spit out whatever the output is. So if you look at the JavaScript, so basically HTML is this. So HTML is like the text, like stuff that you can actually write out. CSS is just and the JavaScript, all of those things. So it's like,
Yeah, that's HTML.
yeah, that's how that.
It's working.
Yeah, it's working. So basically, for this function of this UI, basically it's saying here, it doesn't have to roll lines.
Change you.
This is saying that the variable is saying.
Go back here.
Yeah.
No, settings.
It's just a box. It's just like a regular box. And then it goes to finds this
Shane.
ID. And it finds the value. And then takes
Here, right?
the
Back here. It's
all.
Wait, go back up here.
So it's just that the value string. Turn the string. And then
And the other website.
Yeah,
that's
yeah.
Right?
Yeah, maybe.
Yeah.
Like there's other code that other people will get the element. Just to get element by. I think oh, thank you. This one. So we get the element. So once it fetches from the HTML, it comes here. And then once it all runs, it comes back here. This is all the code I must do, yeah. Explaining kind of rough what's happening. And then this is an automatic decision like because whenever you change it, it wants to like if you change it, you want to update it. That's what this does. Oh. This is add a method. So it's constantly like looking at whatever is here. If I change something, then it's
Oh wait, so I already imported so I don't need this anymore.
I messed it up last. So this. Okay, well that doesn't mean. Okay. Oh. Okay, so you see it's changing, right? Because it's the reason why it's moving does because of this.
Yeah. I think.
Right.
Yeah, like from another website.
This
Oh,
is,
wait, no,
we are,
then
we're gonna
parsing. Yeah.
Okay, did you add that? Did you, give a second?
Should I just keep going?
So we just did that. Yeah, I already did this. Yeah, yeah, it's
Yeah,
right here.
done that.
Except,
Yeah, that way. Okay. Wait, have you
I
ever
think I
copied
put
it? I think you just put it right there.
Yeah.
It works. Very cool.
parsing.
This is what it's now. So now we're gonna create a page.
Oh,
Okay, so now we have this, right? So this guy did date with I
Oh,
input
yeah.
output is a specific thing, and it gives us thing. But remember, this doesn't do anything right now because there's no JavaScript. Now. So this is trying to talk about the pages. So this is the same thing as it's trying to update. This one is
Oh, no, it's just, it's updating years ago, so.
it's fetching it.
Raise your hand if you're doing the Rust version. And then in just a minute, I'll ask who's doing the JavaScript version. I see a couple people doing the Rust version. Raise your hand if you're doing the JavaScript version. All right, I see many more hands doing JavaScript version. All right.
So
just.
Where did it?
So in like 5-6 minutes, I'm going to show the outputs that you should see so that you have an idea of how it can look like. And then you can continue at home. Homework.
If you're doing the JavaScript version, raise your hand if you haven't yet gotten to the point where you have like a text box with a locale that has the locale being canonicalized for you. If you haven't gotten to that point, I'll come help you to get to that point. So you got your HTML code.
Oh.
Okay, and then you need to look at there's different panels you can use. You need to see the output because I'm not seeing the output at all. There.
Oh.
There's some. Okay.
Oh, move.
There's your little.
Hey.
So try like putting in a locale in that box. Try like adding in that box.
right there.
And then if it gives you errors until you get a valid one. There you go. Okay, so you were all the way there. You just didn't know how to. Cool.
Cool. Okay, perfect.
Thank you. Okay.
So
go back there.
Hot step.
Because it says.
They can't find a locale, right? You sure, right? I'm just copy pasting.
Yeah, so
Oh, yeah.
that's in your JavaScript. I see the JavaScript.
Yeah. Which is what we were doing.
Yeah. Okay, cool. That's on this. Cool. So yeah, reference error locale is not defined. So you need to make sure that this is in a function that has locale defined. So you probably want to put it like up here because this is where you get the locale.
But it's not.
But you pasted it down here, and when down here, there's no variable called locale.
So
So
I'm
you,
gonna actually have to switch the order.
you need to put the code inside this update function, inside the right in there, so that you can read the locale variable.
Oh.
Yay.
Okay.
Cool. Glad I could be helpful.
But, let's see. Okay, so this has to go.
file.
Oh, sure.
So that's inside. So that means that.
Raise your hand if you've seen today's date being outputted by your program.
Okay, so-
All right. People are making progress.
Sorry.
Okay, we're going to be slowly wrapping up. It's perfectly fine if you don't have everything. I will now display how it more or less should look like. And
Keep working on your own, and then by the time we finish this, maybe we'll fill in some gaps if you missed anything.
yeah, so my goal is going to be to point out a couple technological solutions that are possible because of that. Because while I understanding that the setup is challenging, if you're getting into a new framework, some things may feel like they're easy or should just work, but they are non-trivial and worth pointing out. So the most important thing, again, is going to be that this website is incredibly valuable for all conversations about what you could do, how to manage data, what is the quick start, like building this date picker is also available here, both general and with custom data. So you can also find it later just out of our website. And now I'm going to show you what I've done with the same tutorial. And it looks more or less like this. So I'm starting with the JavaScript version. It's a little bit extended compared to, I think it's passing part 4. I have a little bit of HTML written. That really doesn't matter what the HTML does. All it does is that it displays this. And a little bit of JavaScript. It also doesn't really matter that much what the JavaScript does. It basically listens to when you change this and calls this. So what I'm going to show is the code has, 30 lines so of DOM-connected JavaScript, so you can play with it later. What is important here is that, assuming I'm successful, the output right now is November 11th. And the language is English. And now if I change the language to Polish, French, German, I'm using local codes, Chinese, Japanese, Arabic, Cyrillic, Serbian, or Taiwanese, I will be updating my my display, my formatting, just as you would expect. Now, if I change my date formatter to date time formatter, and I will do it because I go to my TypeScript documentation, and I find that there is a date time formatter. There's date time and date time formatter, and I can click on it, and it can explain to me how to use date time formatter. It also recommends the Rust documentation because it's a little bit more rich, but it uses exactly the same methods. And because it uses the same methods, I can import it, change here to use date time formatter, change the method, because this is the method provided here, imdt I'm going to use for time, and I pass time as a second argument. And now I have a format with a date and time. And if I change it to 12, 34, in Polish, Arabic, all of that is following the expected pattern. The reason why we showed you this demo is that it kind of contains itself in like 30, 40 lines of JavaScript. But what it also does is that for the first time in the history of our industry, you can do all of this at a very small code base, live in your browser, without pulling a really large, asking all the users of your website to pull all of the data. It's available to you in JavaScript, And the same way as those 30 lines of code handle date and time formatting, you can also do everything else here. Collation, BiDi, decimal formatting, number formatting, grapheme cluster, so line breaking, line breaker, plural rules, sentence breaker, time zone formatting. All of that is available to you exactly just replacing this formatter with another formatter. All of that is continuously available to you, and it pulls what you need. You can, of course, work in much more detail with that, but this is like a gist of, you now have internationalization that is available to you in JavaScript, and here is an analogous work that I've done in Rust. If I can move it. I followed the same tutorial. I result with slightly smaller code base, 21 lines of code, but that's just because I haven't had to do any HTML and there's no user interface. All of my user interface is here in the command line, and I can just cargo run, which is the command that you use to run this program. And then all it's gonna do is gonna format the date. And if I change the language and recompile, now I'm gonna see the date formatted into another locale. You can take this, of course, in your actual code, you're gonna take this locale from the user. You're gonna ask the user, like, what language do you speak? Or you're gonna check in their operating system what language that they use, or in their browser, and format it for them into the language that they speak. But basically, the datetime formatter that we used here is the same as we had before. And you can pass, I'm passing a date, but you can also pass time the same way as we were doing in JavaScript. And again, if I'm curious what else I can do here, I go to the Rust documentation, and I have access to all of those modules. All of them are available to you. It's basically the same code base, but for different functionalities. Not all of that is, of course, formatting. Some of that is pluralization, segmentation, and a growing number of those features are available in experimental, where you have display names, duration, measurements, relative time, unit formatting. All of that is soon to be graduated based on our available time and also prioritization. So if anything from the experimental components you think is important, or you have a good use case for it, please let us know. It'll help us prioritize what to stabilize next. Okay. I hope this was somehow informative. And what I want to emphasize here is that both demos that I showed and gave you an offer to play with have been using exactly the same lines of code. So some engineer who has spent a lot of time thinking about this, like Shane, wrote lines of code, and now you can use it in JavaScript or Rust or Dart or C++ or Java or Kotlin or Swift or any other PHP, Python. You can scale it to other programming languages without having to have Shane code it in another language or someone in that community building an equivalent of that in that language. So as new programming languages come and become popular, our boundary to bring you the same code and the same internationalization into a new ecosystem is going to be much, much lighter moving forward, thanks to the ICU4X architecture. And here's the mastermind behind it. So we can thank him later. We use the same CLDR, so as ICU, which also means that in majority of cases, your traditional software, like operating systems, which use ICU4C, and what you will write using ICU4X is going to look the same. There are some nuanced differences. In a couple places, we made decisions that are moving in a different direction. They are very deliberate. We spend a lot of time going back and forth on in which cases we believe that, for example, different moon calendars in Islamic calendar do not make sense the way ICU4C did it. And that's where we diverge. Always with a goal that we believe that majority of speakers of that culture and language would prefer to see that formatted in this way and will understand it better. or what is the sorting list in Finnish when you're sorting Arabic letters. Those cases we may be changing, but those are very, very rare and far between. And yeah, as I try to show you, I hope ICU4X is pretty well documented. We put a lot of effort into making sure that absolutely everything has a documentation starting from zero principle, and that we do not assume that you have a lot of knowledge coming into it. And you can follow those tutorials. You can paste them to ChatGPT and ask it to explain it to you, and it should be explainable, which hopefully lowers the entry barrier into the project. Okay, so now we're going to talk about something much more complex. Oh, wow, this is much louder. Which is data management. One of the things we glazed over so far is how did the code that you wrote and the code that I showed, how did it get the data? Normally, you don't have to think about this. When you open your browser and you use the browser API, you probably intuitively understand that the browser has the data. You downloaded your Firefox, your Chrome, your Internet Explorer, or any other browser, Atlas, or Comet, or any other browser, Brave, so many browsers now. You downloaded it, and when you were downloading it, it came with all the date format patterns, number patterns, plural rules, all of that was bundled in it. But when you use ICU4X, that's not inside the browser, or at least we didn't use the one in the browser. We used the one that you bundle in your application. That gives you a lot of control, but the question is where the data comes from. So we did this. We were able to glaze over it because we do a couple tricks to make it easy for you to start. But if you ever work in production with ICU4X, you actually have to put a little bit of thought into this because it is becoming a big part of how you ship your software. It's a little bit like if you ship your application, you need to think about where is your logo bundled in your application? Where is the branding associated with the application? Where do you store it? Are you downloading it online? Are you shipping it with the application? If you download it online, what happens when someone tries to use your application offline? Do they not see it as a break? If you ship it with the application, how can you change it? What happens when something has to get updated? So there are a lot of considerations related to data management, and ICU4X does a lot of work for you so that you don't have to think about this. And most of the time, you don't. I've been using ICU4X in production, in my project, and I never had to write this line of code because Shane wrote it. But for this conversation and this part of this tutorial, I am going to give you a little bit of an insight, and it's going to be much deeper engineering conversation. So if it's a little bit fuzzy, that's okay. You have tutorials on the website. But if you have questions about this, please let me know. And I do hope that over the next 20 minutes, we're going to get at least a glimpse of how to think about deciding what data you ship. And that's going to come important if you use ICU4X and your UX department comes and says, no, in French, we have to format the data differently. And if you don't have control over your data, you say, well, but my library formatted it this way. I can do nothing. And your project manager or your employer says, well, we don't care. We have a Figma, and Figma shows month after day, so change it. With ICU4X, you can't. It's not super trivial, but there are tutorials, and we're going to help you work with your own data. So actually, we have a little bit of time. Not a lot of time, but a little bit of time. So the important part, and this is a trait of the programming language we use, which is Rust, is that we have ability to strictly define the minimal amount of data required for a given component. So if you format a date and time, we can declare that formatter requires time symbols because we will be formatting time. Requires time lengths and ordinals. So we clearly define what is the minimal amount of data required by this formatter. If the code here was showing you plural formatter or some other formatter, it would have different data slices required. you can implement your own data providers, and they don't have to be full, but it's an important step in business deployments of ICU4X is that you do control what data you ship. You don't have to. You can use ours. We're going to provide you the good defaults. But in many, many cases, we encounter customers who start using internationalization solution and then run into a problem where they would like to change something. And the process before ICU4X was really painful to do that. With ICU4X, you do have control over it. You can adjust how the data is shipped. It also means that in your business logic, you can separate where you download the data and when from when you use the data. Yeah, so you can look at in the documentation, like there is a baked data provider, which is the one which you've been using so far, where the data is just associated with the code. It looks like there is nothing, but actually you download code, JavaScript or Rust, and it has already some snapshot of the data. It's like, imagine we bundled a piece of Wikipedia into your library so that when you want to format dates, we have something. But when you want to have the latest, you will have to use one of the blob data that are shipping separately the way you would ship any other assets for your application. Yeah, and when you build a launcher formatter, you can select which provider you use. We have some helper functions that kind of hide it, but you can select your constructor with information about where do you get the provider, and then you pass preferences and options into it. And blob data is encoded in just binary format. That is very efficient and allows us the performance gains that I showed before are partially possible because our data is stored in a format that is very, very fast to load into memory and use. Right. So there are also provider adapters which allow you to control how you override data. So it's not a binary choice where you either use full CLDR data or you use your own data or your own copy of CLDR. You can actually chain it where you can pull those two keys for those two languages from your own override, and the rest just load from the ready-made provider. Yeah, so this was, if compiled data is too limiting, you can generate your custom data. And our data is sliced by locals and by, by data keys. This is what I was showing before, is that every formatter and every component has its own selection of slices that it requires to work. And only those slices are needed by the given formatter. So you can narrow down what you use, and you only pay for that, as we promised at the beginning of the project. And here is the second tutorial for you. This one has exactly the same URL as the previous one, with a digit 2 added at the end. That should make it a little bit simpler for you. And this is a tutorial that allows you to play with introducing your own provider. We have 10 minutes left in our talk. My recommendation is that take a look at this, start playing with it a little bit, choose your programming language. Again, you have JavaScript or Rust. I think this demo is even more impressive in JavaScript because the idea of loading your own data into your own library in JavaScript is even more complex, and we made it relatively simple. And I'm gonna try to secure like the last 3 minutes for any further questions and last words.
All right, and if you loaded the JavaScript, or if you loaded the tutorial within the last minute, if you can just reload, because I just merged a fix to some of the links in the bottom of it. So I don't want you to be using broken links.
But I'm like, what do I define time as? I don't have it defined. It's like, I think the HTML is fine.
Yeah, so you go to the date string from the input, you can load the time string the same way. Right. So you copy that line and then should they
Oh, so and then I use that to define.
Yeah, so you can do the same thing, but then make it let time string equal, and then you can use the time input.
Oh.
Right, because this one is reading from the date input, which is right. So you need to load from the time input HTML. You can refer the ID.
Yeah, because in the future, I'd like to write it like defining in these variables so people have a certain.
So now.
It's just,
Yeah, so now she wants to make it show the time. Yeah. So it's working with it. In order to make it show the time, you then need to.
On this, I've deleted it, and it's now it's
The next set of
the.
zero. Because it's still using
defining the same.
YMD. So I'm just going to check YMD.
I want to emphasize that if you are following the tutorial for JavaScript, you actually don't need to install Rust because we already built this payload for you. You can start from the section called JavaScript Part 3 and extend your JavaScript CodePen code just to load this data. The previous section is important if you work with Rust or if you want to understand how to generate your own data.
Yeah, something also that I'll highlight about these these data files that we generate. The tutorial has them generated for the Chakma locale, and this is very cool because I was able to generate these and then put them on like Google Cloud Storage, and then like whenever any user comes with that locale, like they can just load the data with that locale. It's like a language pack, and they can load it into their ICU4X at runtime. So you could, for example, generate the data files you need for your application for like 200 or 300 locales, and you don't have to ship them to every user, but users who use those locales and need them can access them.
Hey, so in the spirit of time, in like around 2 minutes, I'm going to actually go through this tutorial with you, and I'm going to show you what happens in the code here. And then you can follow the tutorial, of course, at home. All of that is available from the website.
They used to be called.
I got this part. Still haven't done that one yet. Oh my gosh.
If you've gotten to the step of the JavaScript tutorial where you're loading in the file, if you get an error function create from buffer doesn't exist. Change it to create from byte slice. That's a that's a typo.
Yeah, here's one.
All right. So I'm going to now present what we've been showing you, and now I'm going to walk you a little bit through what is intended to do. It's all in our ICU4X tutorials. It's all linked from the website, so you can go at your own pace. As you now know, we are also friendly. We are available on Discord and are happy, sorry, on Slack for ICU4X, and we're happy to answer any questions and help you synchronously. So I know it's like not the part that you're after. Like when you think about internationalization, if you have to think about this at all, your goal is like, how do I make my user interface work for people, on the whole planet? How do I make like a couple lines of code so that it displays? So the first tutorial was kind of showing you this. The second part is why the whole industry is actually challenging, because there's a lot of data associated with it. And one of the things we made more ergonomic is generating the data from the CLDR repository. So the CLDR repository is massive. It has data for all the languages. I think I have it here. CLDR JSON, yeah. So like I can show you an example. This is CLDR JSON, and it has all of those, and I can look at dates, and it has dates for all of those locales, and it's just massive number of directories, and for every one of them, it will have something like Gregorian calendars, date fields, time zones, and all of that information, right? So this is what CLDR has. You can play with it by hand. I welcome you to do this, but we've done it for you. And that's what we are doing with ICU4X. It takes this data and translates it into functions that you can call to have the outputs. So if you ever have to play with it, you have an application called ICU4X DataGen that allows you to create for all markers, for all the slices that we talked about, for locales that you want to, which format to store, and which file it'll be created. So here's an example of a file generated with this command. So now how you can use it. So you can load the provider in Rust. You can use Serda, which is a serialization library. And then in Rust, you can say, if the locale of the user is CCP, then we are going to use our own override. Otherwise, we're just going to use the default one. Here, we're going to read from the disk this file, try to create the provider, and create a formatter with this custom provider. See here, there's no provider because there's an implicit one. Here, I explicitly list the provider. And now in my application, the CCP is going to be using a different data that I have control over from my own CLDR. And that, of course, condition can be much more complex. I can say that if it's an A/B testing cohort of users, if those are users who are maybe older or have disability, or for some other reason they want a different type of data, we need to show them different type of data, we do this override. I cannot emphasize how many generations of software engineers wrote millions of lines of code into Windows and Mac OS and Android because that was impossible. So this is a huge advancement, but I understand that like for you, it seems still like a complexity. I promise that those 30 lines of code are gonna pay off one day in your career. So in JavaScript, I'm doing exactly the same. I have a function that loads a blob, loads a file. And if my locale is CCP in the code that I've been using, I fetch it from some cloud storage that Shane populated for us.
Yeah, that's the 2023 link. I need to update also that to the 2025 link.
Oh.
Yeah, the links are correct. It's but the URL and the example needs to be updated.
Oh yeah. Okay. So the datetime formatter here, you're creating it with provider. So you use your custom provider the same way as we were doing this in Rust. And now your output is going to use this formatter. And if it's not this locale, then it's going to use this formatter. So again, the same thing we did in Rust and C++. You can do this in any other programming language that we support. You can customize your data for when you need to customize it. And then the last thing I want to point out is that a lot of challenges in business are still coming back to how many locales we can afford to ship, how much space do we have on a device, at which point our funnel of downloads is going to get affected because we can scale to 30 Indian languages, but it's going to add some megabytes. And those trade-offs are really challenging and end up with internationalization team in your company fighting the product team or some conflict. So ICU4X is helping you get an escape hatch. You can create the data that is only needed for a given program. So we statically analyze your program and we figure out what do you only need. Maybe your program does not format time zones. So why would we bundle time zones? Maybe your program doesn't need some slice of data. You can list the slices explicitly, but you can also just analyze the code. And the nice thing about this is that then if you look at the size of your blob, before that, it was 5.4 megabytes for this single locale. And now it's only 13 kilobytes. Because majority of the data you never use, so we just didn't bundle it. And there's more that you can do that allows you to slice it even further to 4 kilobytes. All of that is not how you start your journey, but we think it's very important to understand that you have this escape hatch, this lever, available to you as you're integrating internationalization into your business logic. And as you start running into people and challenges and questions about, does it have to be 60 megabytes? And this is the question that I have been asked in every company I've ever worked for. And there are cases where, and it trails. So like, I know you have to finish, but I'll give you an anecdote so that you understand why it's relevant. In my last company, we built an operating system, Amazon Vega OS. It's a new operating system released by Amazon 2 months ago. It uses React Native. You can write your applications React Native. React Native is a massive runtime. It's around 100 megabytes. 40 megabytes of that is ICU4C. One of the challenges is that it's unstable. So if you write an application against React Native 67, and then we release React Native 68, your application may not compile on 68. So we need to ship the operating system with 2 React Natives, 67 and 68. Half a year later, 67, 68, 69. Half a year later, 67, 68, 69, 70. We slowly deprecate 67, but it's a trailing combination of React Native versions. If each time ICU takes 40 megabytes on a disk, how many will you fit on your smartwatch? Now, if we can trim it to 4 kilobytes, or let's say 200 languages, 800 kilobytes for all locales, now there's no business problem. We can actually ship it on a smartwatch and release it on a wearable device across versions without inducing a tremendous cost and having tough conversations about which customers are worth supporting. So this is the goal of internationalization, and I think ICU4X advances us in this direction, and hopefully this will help you in your journey, and you will find our library useful. And if you will one day be looking for a fun project to work on, we have a lot of early issues that are looking for owners, and we are pretty good at helping people on board and get their hands dirty and write some code for us. So thank you so much. I hope that this is useful, and have a wonderful evening and afternoon. Are there any questions? No copying. No questions?
I'll be sticking around a little bit to answer more questions if you don't want.
I'll be sticking around a little bit to answer any questions that Shane can.
Oh, the question is, when will the slides be available?
Oh, the slides are available right now. I just don't know how to distribute them to you. So I'm going to do the following trick. Copy link.
Yeah. Okay.
All right. Here are the slides.
I'll go ahead and write that up on the board too.
Ah,
It's
okay. Hopefully this is.
ICU4X 2.
Yeah, thank you for asking. This is. I made a promise and then I was like, oh yeah, we'll figure it out later.
Yes. Yeah.
UTW slides. ICU4X 2.1 UTW slides.
They private.
Share it.
Oh, I have to share it with you. Fine. I'll do that. Should be done. Are there any other questions about our work, Unicode, world of technology?
Here's a mic.
I guess I'm just curious because I know there are panels like tomorrow, like TikTok has a panel of like they use their own, like they use a different library, and I think Adobe and PayPal are also talking. But this is like the base of like, as like, cause like I contribute to like a small open source personal finance budgeting app. So they use Weblate and I18 Next. And since you were literally doing ECMAScript, so I thought this would be a good chance to ask you, but it's just cool if you have any insights. Like it's, the app is an Electron app. And I guess, I mean, I didn't really go too much into the code. I was just kind of just helping like, oh, like what does the architecture look like? And like, how do you like conceptualize all the different stuff? So your diagrams were really helpful. But how does this actually lay into like, say you put this into Electron, it would end up like that, but like on a much larger scale with all the different locales. Like it's a local only app, so there's no server.
So that's a okay. So let me verify if I understand your question. So the example is you're giving is that you work on an Electron app.
Yeah.
That has some internationalization, and currently it's using I18 Next.
Yes.
Library.
Yeah, the JavaScript.
And how does it relate to what we've been talking about?
Yeah.
Is that correct? Okay.
Yes.
So the relationship is that your application uses Electron runtime, which has a Blink engine, which has a V8 JavaScript engine, which links to ICU4C right now, predominantly ICU4C. So when you use that, you have free access to data informator, for example, from ICU4C. Now, if you look at the size of Electron, it's fairly large. That's one of the reasons. What we are working with V8 people on is there a value? Are we ready to start looking to change some pieces of V8 to use ICU4X? But even if we don't, one of the things you will notice is that if your app is successful, you will get to the point where you have a need that works a little bit different than how the browser formats it. For example, the designer of your finance app may come and say, I would like to display currencies differently. It's a very valid question that a lot of people at Amazon are asking. As you can imagine, for Amazon, displaying currencies is one of the main things that Amazon does. It's displaying you how much something costs. And they have particular needs. And if you use what the Electron provides you, you don't have a lot of control over customization or adaptation. So if you have a need and you use the thing that comes with Electron, you can't do too much. Now, that may not be in itself enough justification to say, well, let me use ICU4X here, or it may be. But eventually, as you get more and more, you may have a conversation with your team about whether it would be worth pulling this 80 kilobytes to have things formatted exactly the way you need it. And in the meantime, Shane works at Google and is working with V8 to make V8 smaller. using ICU4X. So it may come from both sides at you. You may use it in a custom way, and the platforms and engines are adopting ICU4X. So for example, users of Firefox will already be using more of ICU4X and slowly V8 and slowly other engines and runtimes as we mature the platform and validate that you can have the same quality at much smaller sizes.
Yeah.
Does that answer your question?
Yeah, that's helpful. I mean, we are having that debate right now, actually. I'm trying to put currencies in like the euro and the US dollar and everything. So that helps to understand there's actually a relation between those two things. Thank you.
Of course.
Cool. Yeah, something else I'll just add to that too. I've been working a lot with, or my team has been working a lot with the Flutter team at Google in order to do the ICU4X deployment into Flutter apps, because right now the Flutter runtime also ships a fairly large ITN solution, and we're working on having them ship ICU4X to help optimize Flutter apps if you're using that framework. I would encourage, I don't have I don't really talk to the Electron people, but the Electron people could leverage this now if they wanted to. They don't even have to wait for V8 to do it. They could do it in a way similar like how we've done with the Flutter team. Also, if there's anyone else who's because I think a lot of people get IE10N through their platform. Not everyone does, but a lot of people get it through whatever framework they're using, right? So we have this available, and please engage, and we can help integrate it into whatever frameworks that you need. The more when people say if you go to the Electron page and file an issue to be hey, Electron is super big, and I want to customize my locales. Can you please consider getting a better solution for how you do the IE10N formatting? That's great. It's really helpful when people like you ask, because I can go and say this is really important. But then it's well, you're just you're an engineer. You say everything's important if it has to do with your team, right? But if there's someone like you who comes and says this is important, then I can say this is important. Look, here's an actual user who thinks it's important, right? And that helps me make the case that we should prioritize this type of work. So.
Yeah, and this is happening right now. So I want to emphasize that on the timeline that I showed you of the history of ICU4X, the first 5 years, maybe the first 3 years, were basically us proving that we can do it. The last 2 years were more proving that what we've done is production ready. This year is really about, we already know it's production ready. Hundreds of millions of users are using software for ICU4X. Now it's the slower process of the rest of the stack built 10 years ago, like Electron, Node being built 20 years ago, slowly moving to that. And then part of that is evangelism. Part of that is facing more constraints. How do you put Node on a smartwatch? You're not going to do it if it's 20 megabytes. You can do it if it's 5 megabytes, 4 megabytes, right? So we can start those conversations, and it's happening right now. We are both following a couple GitHub repos that are right now moving to ICU4X. And validating the value proposition. So this is actually a conversation we would love to have with environments that would benefit from size reduction or performance. My former team at Amazon is looking at using ICU4X for line breaking in Kindle, because there is not only, we didn't show much about this, but the size reduction also means that there is memory reduction, and when there is less memory used on complex scripts like Mer, Tamil, Southeast Asian scripts that have very complex rules about line breaking, actually having such a drastic improvement translates into speed of text and pages and battery life. So there's a lot of far-fetched implications of the work we're doing, but it also is available directly to you. You don't have to wait for the next release of Android or the next release of Chrome. You can use it in your applications right now, and I hope you will consider that. All right, thank you so much.